For decades, scientists have promised a future where electric cars charge in minutes, smartphones last for days, and battery fires become a thing of the past. That dream rests on one powerful innovation: solid-state batteries. But here's the big question: how close are we really to making them a commercial reality? Let's dive deep into the science, the breakthroughs, the hurdles, and what the next few years could actually look like. Before we proceed to the video, don't forget to hit the like button and ring the notification bell so you never miss our upcoming videos. What are solid-state batteries? To understand why solid-state batteries matter, let's start with what we have now: lithium-ion batteries. These power everything from your phone to your Tesla. They work by moving lithium ions between two electrodes, the anode and cathode, through a liquid electrolyte. That liquid allows ions to flow, but it's also flammable, limits energy density, and wears down over time. Solid-state batteries replace that liquid electrolyte with a solid material, something like a ceramic, glass, or polymer. This one change opens a world of benefits. Higher energy density means more power in a smaller, lighter package. Why it's so hard to make them work? Sounds simple, right? Replace the liquid with a solid and boom, problem solved. Unfortunately, that simple swap introduces massive engineering challenges. The first big one is ion conductivity. In a liquid, lithium ions flow easily, but in a solid, it's like trying to run through a wall. When you press two solid materials together, the solid electrolyte and the electrodes don't make perfect contact. That causes resistance, which slows down performance and causes wear. The lithium metal anode, which is key to achieving ultra-high energy density, is also a double-edged sword. In short, the physics are known, but the engineering is brutal. The race to commercialization. Now, despite those challenges, research has exploded in the last decade. Billions of dollars are being poured into solid-state R&D by some of the world's biggest names. Let's look at who's leading the race. Toyota is arguably the most committed automaker in this field. They've been developing solid-state batteries for over 10 years and claim they'll have limited production cars equipped with them around 2027 to 2028. Their focus is on safety, durability, and fast charging, aiming for an 80% charge in 10 minutes. QuantumScape is a U.S. startup backed by Volkswagen and Bill Gates. They're using a ceramic separator and claim their design can charge from 0 to 80% in just 15 minutes, with significantly higher energy density than current lithium-ion cells. They've shown promising prototype results, but mass production is still several years away. Solid Power, backed by BMW and Ford, is a company developing sulfide-based solid electrolytes that can be integrated into existing battery manufacturing lines. They've recently started pilot production and plan to deliver test cells to automakers for validation. Samsung and LG Energy Solution both have announced solid-state breakthroughs in their labs, focusing on hybrid designs that use a mix of solid and gel-like electrolytes for better performance and easier manufacturing. So far, we're seeing prototype-level success and impressive performance in controlled environments, but scaling up to mass production remains the hardest step. Manufacturing challenges. Here's why scaling is such a nightmare. Material sensitivity. Many solid electrolytes are extremely reactive with moisture and air, meaning they need to be manufactured in ultra-dry environments. Precision requirements. The layers must be thinner than a sheet of paper, perfectly uniform, and free of defects. High cost. The materials themselves, like lithium metal and ceramics, and the specialized production equipment, make them several times more expensive than lithium-ion cells. Today's factories simply aren't built to handle that. Retrofitting or building new ones could cost billions. That's why most experts predict commercial viability at scale won't come before 2028 to 2030, at least for electric vehicles. The hybrid approach, a step in between. Recognizing these hurdles, some companies are pursuing semi-solid or hybrid batteries as a bridge technology. These designs mix a small amount of liquid or gel with a solid electrolyte to reduce resistance and improve manufacturability. For example, Chinese battery maker CATL, the world's largest, recently announced a condensed battery that uses semi-solid components and claims an energy density of 500 watt-hours per kilogram. That's nearly double today's lithium-ion batteries. These hybrid solutions may be what hit the market first, while true 100% solid-state designs mature in the background. Why solid-state still matters? Even if commercialization takes a decade, the potential payoff is enormous. For electric vehicles, a solid-state battery could mean 700 to 900 kilometers, 400 to 550 miles, range on a single charge, charging times under 15 minutes, virtually no fire risk, weight reduction of up to 30%. For consumer electronics, imagine phones that last 3 days, or laptops that never overheat. And for energy storage, solid-state could transform how we store renewable energy from solar and wind, enabling more compact, longer-lasting storage solutions that don't degrade as quickly. So, when can you buy a car or phone powered by a solid-state battery? Here's the realistic timeline: 2025 to 2027. Early hybrid solid-state or semi-solid designs in premium electronics or niche EV models. 2028 to 2030. Broader rollout of solid-state EV prototypes, limited commercial fleets. 2030s. Full-scale mass production, price parity with lithium-ion, and widespread consumer adoption. It's not right around the corner, but it's closer than ever. So, how close are we to solid-state batteries? We're closer than ever, but not quite there yet. The science is solid. The prototypes are real. But turning them into affordable, mass-produced products is still one of the toughest engineering challenges of our time. If current progress continues, this decade could finally see the breakthrough we've been waiting for in a world powered by batteries that are lighter, safer, and built to last. Until then, the solid-state dream remains just a few volts away from reality. If you enjoyed what you saw, don't forget to hit the like button and ring the notification bell so you never miss our upcoming videos. Your support means a lot to us. Take care until the next one, and feel free to drop a comment sharing your thoughts. See you soon!